All right. Today we will be talking about the law of logarithmics. These are some algebraic properties for logs we can use later to solve log equations. Let's see what they are. First, the law of logarithmics. Okay. So far, everything we know about log come from exponential because they're inverse function to each other. There's no exception for the law of logarithmics. They come directly from the law of exponents. So let's see what we have for exponents. Number one, if I have 2a, x times a to the y, it should equals to a x plus y. For example, 2 to the 3 times 2 to the 5 equals 2 to the 8th. You simply just add them together. That's the first property of exponential. The second property is similar. If you have a to the x, a to the y, that equals a x minus y. This comes from, if you have 2 to the third divided by 2 to the 2, you have 2 to the 3 minus 2, which is 2 to the 1. It's very easy to understand because 2 to the third means 2 times 2 times 2 for 3 times. Then 2 times 2 for twice. They cancel. The only thing left over will be how much this one has to be more than the one on the bottom. Because everything's similar, and everything will cancel each other. And this one has some left over. Okay. Finally, we have the last property. A to the x to the y is a x times y. That means 2 to the square, then to the cube, is going to be 2 to the square times 2 to the square times 2 to the square for 3 times. It's the same as 2 to the 2 times 3, which is 2 to the 6. You multiply them together if you have a power, and then you have a power again. These three properties are very easy to understand. Okay. Now, we want to have the equivalent law of logarithmics by taking the log of these three laws, and by changing the variable a little bit. So what I'm going to do is I'm going to take each law, okay? I am going to rewrite a to the x equals a capital A, b to the x, a to the y equals capital B. They're different. And then it's easy to see x equals log base a, and y equals log base a, b. All right, with this setup, which is just a change of notation, we take the first one. Now we change it. It's nothing but a and a b. Okay, let's write things here. And then let's take log base a on both sides. We have the first law. Of the log property. That is, if you have a multiplication within the log, you can split them into a summation. Similarly, take the second part. I will do it quickly. A over b equals a to the log a minus log a b. Remember, this is x, this is y. We just changed it in a different name. Okay. Then, if you take log a on both sides, we can see the log will take a dividing and change it into subtraction. Property 2. The third one, I will skip how I derive it. You can repeat whatever I just did. But basically, it means log base a to the b equals b log a base a, which means you can take the power and bring it down to the front, so the power become multiplication. That's the three laws of logarithmic. Okay, let's repeat. This one change multiplication to be addition. This one change divide into subtract. And this one change the power to be the multiply. That's the property of the log. Okay, so some quick examples. Log base 2, 4 times 8 equals log base 2 to 4 plus log base 2, 8, which is 2 plus 3, which is 5. Now, if you really want to do it directly, you can also do it like this. That is log base 2, 32. And use your imagination. 2 to which power is 32? You will figure out it's 5. From here, you can see they're equal. It doesn't matter which way you do it. You got the same number. It's thanks to the property. Okay. Similarly, if you have log 16 divided by 8, what is it? Well, it's log base 2. 2. So the answer should be 1. Right. But let's use the property, which is log base 2, 16 minus log base 2, 8, which is 4 minus 3, which also give you 1. Finally, log base 2, 4 square, which is log base 2, 16. The answer should be 4. But instead, what you can do is you can take the 2 out, just do 4, which give you 2 times 2, which is 4. So again, you got the right answer, according to the property. So that's all the properties of log. Why is it useful? Now let's try to see the applications. It's useful because you can use it to expand, or you can use it to combine log expressions at your will. I will show you what I mean by this. Number 1, expanding. For example, you have something look like this. Let's just take ln for simplicity. A big chunk of things. And we have x minus 1 square, x plus 3, negative 3, divided by x times square root of 1 minus x. That's one log with a big chunk of terms. Now when we say expand, what do we mean by that? We mean we use the log properties, we split this one big thing into multiple smaller smaller terms, and each term is way simpler. To make your ideas clear so you don't forget anything, I would personally suggest always do rule 1 first, 1 and 2 first. So handle multiplication and dividing. Okay. Multiply with this, so plus with this. Remember, multiplication is addition. Divide by x. Divide by x again. Okay, so we have 2 minus because these two are on the bottom. If it's difficult for you to think about, another way you can do is you can combine these two and then make a plus because you have a multiplication here. But you need to put a parenthesis because these two goes together. Then when you spread, you will see when you distribute the negative 1 into the parentheses, you have negative. Okay? Or you can think about 4 divided by 2 times 3 is the same as 4 divided by 2 and then divided by 3. So minus and minus again. Either way. That's the first step. We handle everything except for the power. Up to now, every single term should only have one term. There's no multiplication, there's no dividing anymore. Then the second step, you can take this out by putting down the power, which you can combine later to be minus 3. Okay. Notice square root is the same as to the 1/2 power. That's why I take the 1/2 power in the front and leaving only 1 minus x. All right. Up to now, check your work. What do you have? You have 4 terms. Everything inside ln will be power 1. Okay? If it's power square, you can take the square to the front. So make sure everybody is power 1. And every single one only have 1 terms. There's no multiplications anymore. Nothing like x minus 1 times x minus 3. If that's the case, further split. So up to here, you have finished expanding. That's your final answer. So what did you do? You take one big chunk of log, you split it into multiple smaller log, and each log becomes simpler. That's a trade-off. Instead of doing one giant, big, complicated thing, you do multiple, smaller, easier, but you do have more things. This is called expanding. And of course, we use the properties. When you see a multiplication, you do plus. When you see dividing, you do minus. When you see power, you do multiplication. Why do we want to do this? Sometimes we prefer simpler things, even though we have more. That will be super handy later. If you take a calculus, this will be super good for taking the derivative. For now, we probably won't see too much of the application, but later this becomes super nice. The reason is because for derivatives, we want to avoid multiplication or quotient because they are difficult. But addition and composition is fine. Even that means we need to do more of them. Okay, as long as we don't do multiplication and the quotient, it will be fine. That's called expanding. The second way is called combining. This will be super useful right after this section. We will show you. It will be super useful for solving log equations. The reason is because if you have multiple log, if we can combine them into one single log with a big chunk equals something, then after that we can do the a to the log to cancel everything, so the log will be gone. We can change everything into exponentials. To do that, we need one single log. Later we will show examples. Okay? For that reason, we do exactly the opposite. So example, combine the following expression . Let's do a 1/3. Okay. Into one single log. How do we do it? Well, do you realize this is exactly the reverse of what we did before? Before we take one giant one and split them into multiple smaller ones. Now we take multiple smaller ones and rework them to make them the giant one. That means you should take the step 2 here to be the step 1 here. And you take the step 1 here to be the step 2 here because you're working backwards. So step 2, the first thing we do is we handle the power. That means here, step 1, we should handle the power. This is tricky. We will save it. You need something like this, right? But this is a 2. You can simply do that to the 1/3. You can write it to be the cube root, or you don't have to. Here, we know we want ln, but we also want to keep 2. So the only way to keep it unchanged is do ln and then do e, so they cancel out. That's how we did this. Once we have that, the second step, which is the first step we just did, we do the multiplication and we do the dividing. Okay. Minus divide. Minus divide. Plus multiplication. Now check your work. Do you have a single log compared to multiple logs? The answer is yes. The trade-off is everything becomes super complicated, but the good news is you only have one term now. That will be the final answer for combining into a single log, because for now I do have only a single log. Okay, this will be very useful, we will see right away, of solving log equations. In our class, we will see this direction more often. Okay, the first one, you will see it in taking derivatives, where you do something called the log differentiation. But for now, we won't see much. All right. That's the two things we will do with log properties. Later, we will show you how to do it for solving log equations in the next section. So finally, we only have one thing left over. That is the change of base formula. This is not a very important formula, but we do want to use it in our class for a few examples. It comes from this. Let's see. If you're taking the log base A and log base in terms of B, okay, it's the same as log base C B over log base C A. And here, the choice of C is arbitrary. That means you can pick anything. Pick it to be 2, it's fine. Pick it to be 3, it's going to be fine. That's the change of base formula. How do we use it? What is this? Okay. If you think about it, you're looking for 4 to which power is going to be 8. It's hard, right? That's why we say, well, this is hard to do directly. Now, according to the formula, I can change it to be this. A, B, put them in the right direction, right position. Now I can pick any C here to make my life easier, of course. Can you see that if we choose everything to be 2, this will be super easy to do. Okay, that's where we use the change of base formula. When you have two things you see clearly they're related, but they're not exactly related by integers. Maybe it's useful to use a third party, which will actually give you nice numbers for both numbers in order to do this. Another example is very easy to think about. For example, log base 927. Number 1, 9 to the 1 is 9. Number 2, 9 to the square is 81. 27 is neither. Second, you do know these two should be related. They are all related to 3. Therefore, why not we do this? And then we have 3 over 2, and that's the answer. Okay. That's basically where we're going to use the log, a change of base formula. Okay, to have the base we want, we desire. Why this formula works, I will just take this example and show you. Remember, you're trying to say, hey, 4 to which is 8. Now, if you think about it, what you can do is you can change this to be 2 square to which equals 2 cube. Right? Now you know this number you're missing is 2. 2 times what equals 2 to the cube. Now you know this one equals 3 over 2. I better not use this one. Let's just change it, give it a name. So can you see that? By changing a base, by picking a 2, in the change of base formula is the same as picking the base here for 2. Then 8 and 4 become easy, and finally, all you need to do is worry about is just the two numbers in terms of this new base you just picked, which is 2. Okay, that's where the change of base formula comes from and why it works. All right.